So, where is groundwater actually stored? And more importantly, how is it stored? As you might imagine, the storage capacity of the underground rock differs depending on the type of rock it is. Write in your notes that the storage capacity of a rock has to do with its porosity, and you see the word right here, porosity, which is the percentage of the total volume of the rock or sediment that consists of voids or pores. There's where the word porosity comes from. Also get in your notes that these pores or voids are determined by three things that we want you to write down. Number one, the size and shape of the grains in the rock. Number two, the packing of the grains, or how close together the grains are. And then three, the sorting of the grains. In other words, how the grains are arranged, like big next to small, etc. So if we look at this diagram, we can see some examples of rock with different porosities. For example, A has really small grains. You see rock A now has really small grains and lots of space in between them. So water would move freely through this rock, whereas rock E has very little space. Therefore, water would move much more slowly through this kind of rock. So we call that porosity. So here's a closer look at what we mean. We see that even sandstone has a variety of grain sizes that can affect how water moves through them, right down to clay, which has almost no space between the grains. All of this leads to a concept we call permeability. So porosity leads to a concept called permeability. So write in your notes that permeability, and you see the word right here, so you have to worry about how to spell it. Permeability is the ability of a material to transmit a fluid, in this case water. And that permeability has to do with the interconnectedness of the pores, which again you can see here in this diagram. So if we were looking now at the permeability, or the ability of water to move down through this rock, we can see now as we move from left to right that water now is allowed to move more freely on the right hand side where you have spaces in between than on the left where there's none. Also get in your notes that shales have a low permeability because they have very few pores, and also because these pores are not interconnected like you see here on the left side of the diagram. On the other hand, sandstones have a high permeability because of two factors you can guess, right? Because they have pores for sure, but also because the pores in this rock type are interconnected like you see here on the right. So on the left would be something you would see in a shale, and on the right is something you'd see in something like a sandstone. So left, not very permeable. On the right, much, much more permeable. Okay, now let's move on to aquifers. Write in your notes that an aquifer is a body of saturated rock or sediment through which water can move easily. And write that it's composed of an underground layer of water-bearing permeable rock, or what we call unconsolidated materials, such as gravel, sand, silt, or fractured rock. Now, and I'd like you to write down that because of that, groundwater can be extracted now using a well. And you see an example right here of a couple of different kinds of wells. And we're going to talk in more detail about wells here in a second. Also get in your notes that the study of water flow in aquifers and the characteristic of aquifers is called hydrogeology. Hydrogeology. Hydro means water, geology means rock. So literally, you're studying how water moves through the rock in hydrogeology. Also write in your notes that an aquitard, you see an aquitard right here, an aquitard is rock or sediment that retards groundwater or slows it down or prevents it from actually moving due to low porosity and low permeability. And obviously that would be made of something like shale or clay or unfractured rock. So aquifer and aquitard. So aquifer is freely flowing water. Aquitard is something that retards or slows down the water flow. That's the difference between the two. Got to know the difference. Okay, so there are two main types of aquifers we want you to get in your notes. First is called an unconfined aquifer. So write that down, an unconfined aquifer. You see it written right here. An unconfined aquifer has a water table. Now, water table, you see the water table here? Remember that the water table is the upper part now of this aquifer. The very top part is called the water table. Now, this water table is only partly filled with water, and where the actual top of the aquifer is exposed to the atmosphere like you see here in this diagram. Now, also write that unconfined aquifers are rapidly recharged by precipitation. Recharged means refilled. So aquifers are rapidly refilled or recharged by precipitation infiltrating down into the saturated zone. So you can see now these arrows now. Water would, for example, if it rained, water now would infiltrate now through this soil and rock back into the water table. We call that recharge. All right, and the top, very top of this saturated rock zone is called the water table. So, two things from this diagram: unconfined aquifer, water table, and then how that water table is recharged. So let's move on. Okay, next write that a confined aquifer is completely filled with water under pressure and is separated from the surface by a nearly impermeable confining layer or aquitard. All right, so we're working with confined now, not unconfined. So now you're seeing now water that's surrounded by impermeable rock. So here's our water table. You see that right here. Here's our unconfined aquifer that gets recharged by water that moves through. Now down here, we see two big layers of rocks surrounding this area. Both of these are confined aquifers, which means they have big, thick layers, probably of shale or clay, that surround them. Now, write in your notes that we can access the water in these confined aquifers by two different kinds of wells. One is water table wells, and the second one is an artesian well. So let's take a closer look at those two. So again, you got to differentiate between an unconfined aquifer and a confined aquifer. Unconfined has access to water from the surface, and now the confined aquifers are surrounded now by these big beds of shale. And you can see these wells now. This one's sunk into an unconfined, and this one's sunk right down into a confined aquifer. Now let's look at the types of wells that take advantage of the different types of aquifers and get them in your notes. First, write that a water well is an excavation or structure created in the ground by digging, driving, boring, or drilling to access the groundwater in underground aquifers. Also write that the well water is typically but not always drawn by a pump. or using containers such as buckets that are raised mechanically or by hand. So again, here you see a dug well right here in this bucket now that would reach down into the well and have to be pulled out. Here you see a driven well, and then here you see a drilled well. Typically, these two would have some kind of a pump associated with them that would pump the well out of that aquifer, or the water out of that aquifer. Now, there are three types of water table wells we want you to know about and describe. Again, the first is the dug well. Write that historically dug wells were excavated or dug by hand with a shovel to below the water table until incoming water came in faster than the diggers could bail it. So that's called a water table well. Now, the well was normally lined with stones, brick, tile, or other material to prevent it from collapsing, and was then covered with a cap of wood, stone, or concrete. Now, do you foresee any problems here? Well, one of the problems is that they can't be dug much deeper than the water table. Just as you can't dig a hole very deep when you're at the beach because it keeps filling with water. So it's really hard to make these dug wells very deep because they keep filling up with water. All right, next is the driven well. Write that the driven wells are built by driving a small diameter pipe into soft earth such as a sand or gravel. Now a screen is usually attached to the bottom of the pipe, and you can barely see it, but there's a screen right here. A screen's normally attached to the bottom of the pipe to filter out sand and other particles. Now, problems with this well? Well, they can only tap shallow water. And because the source of the water is so close to the surface, contamination from surface pollutants can occur. So, a little bit better situation than the dug well, but still close enough to the surface that it can be some hazardous situations. All right, lastly is the more common drilled well. Write in your notes that most modern wells are drilled, which requires a fairly complicated and expensive drill rig. And that drill rigs are often mounted on big trucks like you see here. Actually, that truck doesn't look that big, but the rig is mounted on the back of it. They use rotary drill bits that chew away at the rock, percussion bits that smash the rock, or if the ground is soft, large auger bits like you see people drilling holes in the ice with an auger. Well, they would do the same thing in soft earth with a drilled well. Drilled wells can be more than 1,000 feet deep, and often a pump is placed at the bottom to push the water up to the surface. Okay, another kind of well is the artesian well. Write in your notes that an artesian well is a well in which water rises under its own pressure without pumping. There are two kinds of artesian wells to get in your notes. First, write that the non-flowing artesian well, where the water does not reach the surface like you see here in the diagram, a non-flowing artesian well, okay? And the flowing artesian well, where the pressure is great enough for the water to rise all the way to the surface and flow freely from the well. The name artesian is derived from the word Artois, which is a spot in France where such wells were sunk as early as 1126. So non-flowings don't make it to the surface. Flowing artesian wells make it to the surface, and the key is they both have their own pressure, so no pump is required. Okay, that's it for part 2 of our discussion of groundwater. So take a picture of those notes, send them to Moodle, grab the study guide, answer those questions, and I'll see you back here in part 3. Bye.